Hey everybody, this is Larry. This is day 6 of the July Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. Today we have I don't know, a weird problem, I suppose, an API-ish problem. Yeah, it's Saturday. I slept a lot. I ran 4 or 5 miles or something like that. Just very casual, easy miles to kind of just Though it is very hot up here in New York City, so yeah, that's just my training and not much. Just more of a rest day, honestly, mentally and physically. Yeah, quit my apartment, but that's another story. All right, let's get started. Today we have 1865. Find pairs of a certain sum. Okay, so you're given two integer arrays, and you want to implement a data structure that supports two queries or type of queries. Add the positive integer to element of a given index in nums2. Count the numbers pairs such that nums1 plus nums2 is equal to the target, I suppose, right? Okay. Yeah. So I guess this is like two sum, but dynamic, right? So I think the way that we want to think, I mean, this should be pretty straightforward. Keeping in mind that here, I think there's nothing. That crazy about it. Yeah, I mean, I look at the constraints is actually a little bit different. Because honestly, my first intuition is just try to think what is the best way to do it, right? But now that I look at the constraints, and maybe I should have looked at it a little bit quicker. I mean, I don't know, it's within 5 seconds anyway. You can see that n1 and n2 is asymmetric in terms of length, right? So that's number one. So n1 is much smaller, so we should be figuring out how to take advantage of it. Length 2 is 10 to the 5th, that's big. The numbers range don't, means that there's nothing substantial. But the key thing is that there's only 1,000 cores to count at most and add, right? That means that, well, if you're only making 1,000 cores to count, then you can loop over all of n1 pretty easily. And maybe this is why this is a medium and not a hard. Because now 1,000 times 1,000 is 1,000,000, which should be fast enough. And that's the general idea. That's what I'm going to do. Give me like 20 seconds to drink this water, but also think if there's a cuter, smarter way, right? Can we pre-figure something out? And I don't know that you can. That's why I'm struggling, because given a certain sum, I mean, at least not without pre-processing of n1 and n2, in which, well, there's just a lot of numbers to pre-process, and then make some dynamic changes to it. But yeah, all right. Well, I mean, it is what it is. So let's go. So nums1 is to go to nums1. So I've done nums2 is to go to nums2. Right? Did I understand this right? Yeah. Yeah. Sorry. There's still something interesting here for sure, though, which I guess I kind of skipped ahead because I don't know. I'm still trying to figure out if I could do even better. But yeah, but the idea here is that for nums2, we actually don't care about the values of nums2, except for when it comes to adding, right? And what I mean by that is that we only really care about the frequency of them. So maybe you want to write something like that, because then now for each number nums1, you can figure out the lookup in the what nums2 has to be every second, right? So if we add value of the index to nums1, then maybe we have like so you want to write something like nums2 of index plus you go to val, right? Which is fine, but then maybe you want the previous value, right? And then the after value, previous, next value maybe. Next is not quite right. After, is 0 self.nums2.index subindex, right? And then now self.f2 previous subtract one case, f2 of after we went by 1. And the key thing here is that now for count, now we can do the O of count times O of n1, the 1000, right? Because then now we can do for x in self.nums1. Then now it's just a different thing every time, which is that we have x plus some numbers in x2, let's call it k, is equal to target, right? And then subtract x from both sides, and you have k is equal to target minus x, and then that's what the frequency table is for. So then we have just self2 target, or told, I guess, minus x, and that is to count. Oh, let's quit this. And that's it, really. Yeah, it's just about keeping track of a lot of stuff. Hopefully I didn't misread or make a silly mistake. Maybe you can do smarter, I don't know, but I was wondering whether we optimize it this way, but I don't know, because total is not constant, right? But maybe there's some like Fourier transform shift convolution way of thinking about it, but that is way beyond the scope of for me. So that's what I have for this one. I'm gonna do the bi-weekly contest at some point soon, so let's call it a day. So yeah, thanks for watching. Have a great weekend, everybody. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.